Good morning, all of you. Welcome to this Atal's Faculty Development Program based on blockchain and its technologies. For this first session of this Atal's FDP, we have with us Dr. Mukesh Mohania. He is a Dean and Professor in Indraprastha Institute of Information Technology, Delhi. And he is having a great research experience in blockchain field. And today he will share his experiences and his knowledge in blockchain with all of us. So welcome, Dr. Mukesh Mohania ji. I welcome you on behalf of SKIT family for this Atal's FDB program. Over to you, sir.
You can't see my screen now, right?
Yes, sir. You need to share your video, sir.
Yeah. My 1 sec. Okay.
Yes, sir. Your slides are visible, sir.
Visible? Wonderful. Okay, let me move the bottom here. Okay, great.
Sir, you can start your video also, sir. Your video is not visible now.
My video is not visible? Okay.
Yes, sir. Start video. Yes.
Can you see now?
Yes, sir. It's perfect.
Okay, wonderful. So, good morning, everyone. Okay, good morning, everyone. This is Mukesh Mohania. Good morning. So, thanks to the organizers, first of all, for inviting me here. This is really great to see you all here. I know it's a bit early in the morning from Delhi or from North time. It's a winter time now. But I'm really glad to see you all here. And this is the first talk. What I have done basically, I have divided my both talks into 3 parts. In the first part, I will cover very quickly because about the blockchain basics, very high level things, right? And in this session, I will also cover what are the interesting research issues in the blockchain area, right? And not from a crypto point of view, but more from a database, from a scalability point of view. And in the second talk this afternoon, I'm going to talk basically very interesting applications that we have been developing about in the blockchain area. Okay, so let's make this session interactive. Okay, so first, the blockchain. Honestly, there is a lot of hype around the blockchain. And if you look at the Google Trends and do the comparison of machine learning, AI, and the blockchain, how people have searching the documents on the Google, that shows their interest over time. And I've taken basically the last 5 years timeline, the trends here. And as you can see in the blockchain, which is a blue line, that there was a spike in sometime basically end of 17 or beginning of December. And then basically this spike came down and is going down on that, right? And this is really very interesting. And this is true in one sense that in industry, from an industry perspective, if I look at, because I came from industry, there was a lot of basically buzz around the blockchain. Blockchain technology can solve all the problems basically that industries are facing. And then people have started basically investing some money, right? They were typically basically doing the experiments on that side, and group of companies, they were meeting together, building their consortiums to basically build some different version of the blockchain, right? So this is basically the hype. But if you look at the ML and AI, they are more or less constants basically. And indeed, the adaptation of ML is going up in the industry, right? For number of regions, as we all know, right? So the first questions that arise, and many people have this conception that blockchain can solve everything, right? So there is a lot of hype around blockchain than the reality. So the first question that arises, somebody asks that, can you tell us when we should use the blockchain? And this is a very nice flow chart here. When do we really need a blockchain? So let's say you are developing an application, and if that application requires a database, right, then test it the next one. So if that application does not require a database, you can develop that applications by accessing the data from a file system or any things, then you don't need a blockchain. And if, let's say now, if it needs a database, and there are many people are there who are working on this database, and these people are doing some kind of operations on this database. Some of them may be reading, some of them may be writing, some of them basically editing this data, right? Then let's see basically all these people who are doing something or else on this database, do they trust to each other, right? If there are not many people, then you don't need a database. Then probably you can do the things using the centralized database. Okay. But many people are involved in executing that transaction or the part of the transaction, and each entity or each party they are either reading or editing or writing or updating, means they are doing some operations on the database. They are changing the state of the database, and there is no trust between them. Then you need a database, and if there is a trust between them, then you don't need a blockchain, right? So again, if there is no trust between them, then you need a blockchain, right? I said wrongly database. You need a blockchain technology to solve that application. So that means, in summarize, so remember, this is thumb rule. And again, I keep getting many questions that students are, sir, I want to basically, can you tell me how can I use the blockchain, right? So there's a lot of hype. Again, I'm saying the blockchain, the first test of the blockchain, should we need the blockchain or not, is when you are developing an application, or you are doing a particular transaction, and that in that transactions multiple parties are involved in executing that transactions at some point of time, either in order or in parallel or based on some dependencies or whatever, right? But key idea is when multiple parties are involved in executing the part of the transaction, and there is a lack of trust between these parties, then you need a blockchain. Okay. So by now you have understood when do we need a blockchain technology for the development of the application. So trust, multiple parties, right? These are the two, and you need a database. These are the three basic properties here, right? And we will see more. Okay. So the outline of my talk is, in this lecture, I'll give you the blockchain basics. Particularly, I will cover the permissionless and permissioned blockchain, right? And how my transactions get executed, how the transactions basically they interact or my blockchain interacts with the ledger. Okay, and we will see that. And then we will devote roughly 1/3 of the time is in the very cool research problems which are open, right? And one can go and basically solve these problems, right? You can give it to your PhD students or master's students and really publish cool papers out of it, right? And in the last part, that is the second part of the talk, which is this afternoon, I'm going to talk basically various applications, but particularly I will cover the micro insurance and the decentralized education, because we have seen the new education policy. Now, how we can apply the blockchain to implement the part of the new education policy, and this is what we are going to spend more time. And if time permits, we will discuss about the digital identity, the self-sovereign identity, right, which is very important, and also how my distributed artificial intelligence can be used basically for learning and the blockchain underlying database to establish the trust between the distributed parties in the network. Okay. So a blockchain, many of you may be knowing, basically it was proposed by a person, an unknown entity. We don't know who is this guy, Satoshi Nakamoto, right? He basically proposed this in the digital currency, which you know basically is the Bitcoin. And it is an open, public, and permission-led environment that he developed. And then after that, basically the numerous organizations, the many companies, they have come together and they have started building their own blockchain network, right? And for various aspects of this, right? Some of them are basically solving how my data can be handled underneath, how the consensus algorithms, by different verification, scalability, the throughput improvement, and so on, right? And some of these, they started building these networks, blockchain technology, particularly with the permission one, right? And then they started using in some of the applications, shared KYC in the financial domain, Nostro, right, for tracking the goods and so on, right? And from a business perspective, though many companies have invested a little bit, right, they are still basically doing the experiments to see basically whether this technology will really solve their problem or business problem or not. But nonetheless, basically that there is a market of this technology, right, and which has been estimated of roughly $7.7 billion by 2024. Okay, so let's see first what is the problem. So remember our blockchain definition. When multiple parties are involved in executing a single transaction. So transaction is, let's say basically you want to send X amount of rupees to your family member who's studying in, let's say, in another country. So you want to do the money transfer from one country to another country. So this is a transaction. This is a one single transaction. So in this single transactions, multiple parties are involved. You go to basically your bank, right? That may not be the basically the one that can do the financial transactions or overseas transactions. So what they do, they have an account with the bigger bank like State Bank of India or HDFC Bank or ICICI Bank, who have the license to transfer the money. That money basically to go to the SWIFT organization, right? Then SWIFT to basically there are other couple of other parties go to the destination. From that destination that goes to the your local bank or destination bank, right? So there are multiple parties are involved there, and each party is basically transferring the money to the next person, right? But today, how this is happening, when the money is transferred from third to fourth party, the first party is not aware basically where is the transactions, where is the status of the transactions. And since they're not involved, therefore they also do not know, right? So in the today's of events is becoming a lot more complex, where basically the parties are talking to each other. In reality, basically, they need to talk to each other so that they bring the transparency in the system. They know basically, okay, the money has basically is on the final stage to transfer the money from the head office bank to the local bank, right? So in today's business, it is very inefficient, expensive, vulnerable, right? And there is a lack of transparency. So this problem, when you have lack of transparencies, there is a lack of trust between them. They want to basically bring the efficiency. Blockchain is the answer. So first, let me read the definition. Blockchain is a decentralized computation and the information sharing platform. What does that mean? That means that all the parties which are involved in that single transactions or a group of transactions, you bring all of them on the network so that when one party performs any transactions, then all other parties in that network, they know what is going on, right? So you bring basically the transparency in this system, right? And that is what is the basically is one. And when you means that when the network takes a decision, when some party takes the decision, it is through the consensus, right? So there is a consensus. You know the provenance of that information from where it has been originated. And immutability means basically that if one node has done anything, it is written on everywhere in that network. So now if some guy has a malicious intent and try to change that information, right, he or she can change that information, but the whole ledger basically becomes corrupt, and we will see how it becomes the corrupt, right? So that is what basically the blockchain requirements. That is the requirements is the shared ledger. That is basically that every node in the network maintains a local copy of the global data sheet. That means that all the data is replicated, is fully replicated to all the nodes in the network. And it is append only data. That is, you cannot go and delete the information from that ledger. If it is a deletion, then basically you do that and then mark basically it is a deletion of that data. But you cannot go and delete that data. So say ledger is just like a bahi khata, right? So typically what happens basically when in Seth and Sahukar on that times, basically they go and enter the information, and that same information is basically that guy said do the replication in 2 or 3 bahi khata, so that basically the information is consistent everywhere, right? So that is one. Second is when a query gets executed, right? The query could be a data read one, or it could be a single transactions where you're writing something on the ledger, right? Any transactions that happens, it happens based on the certain agreement that has agreed upon with multiple parties. So if guy 1 is transferring some money to another guy, right, to another guy, that transactions gets executed as per is the contract the signed between the two parties, right? So if I transfer a lakh rupees to someone in lieu of basically transferring the car on my name, that is I bought, so that is an agreement that I will transfer the money in lieu of basically the car that he has sold that to me, right? So there is a smart contract and it is defined in terms of the business terms, which is embedded in the transaction database and executed whenever basically the transactions get executed. It's a simple thing, right? Right, and this transaction get executed based on the consensus. It's not like basically if a transaction has been submitted to node 1 basically executes and give the answer to that one. No, it doesn't work in that way. The same transaction will more or less basically will get executed in all the nodes in that network. Each of them basically say, hey, my answer is 50 rupees. Another say, my answer is 50. A third say, my answer is 50. Fourth one say, my answer is 52. It means there is some problem there, right? So the network decides that what protocols, consensus protocols they need to follow in order to validate the block of transactions, right? And the last part is that everything is secured, authenticated, and verifiable, right? So it ensures basically the complete visibility on that. In that way, basically, as you can see, we are removing the trust, right? Earlier, there was no trust that two parties can be beimani of things. Now it is consensus. One node can be a Bayman, but others cannot be one, right? And the network will basically get to know who has the malicious uh, uh, intent in the network, right? So now blockchain is completely decentralized, right? So as I said, basically when they execute the transactions get executed in all the nodes. All the nodes basically participate in the execution and they tell, hey, the answer of this query based on my ledger is 50, 50, 50, right? Because everyone has the same data, is a fully replicated data, right? So now in the database world, we were going a complete centralized. Now we are going to complete decentralized. So the degree of centralization, that is from 100% centralization to 100% decentralization. And the idea for the 100% centralization, the transactions throughput is very good. You can execute hundreds of transactions per second. If you look at any database, IBM DB2 or Oracle or Postgres or MySQL or anyone, they basically get millions of transactions per second, depending on basically how do you configure on that, right? So that is as you move towards centralization, you basically achieve more scalability in the transactions throughput. Whereas if you go to more to the decentralization, that means you are scaling to the large number of nodes, but the transaction throughput gets degraded. It really hampers. And the reason it hampers basically because everyone has to execute the query, then they need to get the consensus, then they need to validate that, right? So there is a lot of things are involved over there, right? So there you need a one block global blockchain like a Bitcoin or Ethereum. And whereas basically you go to the more on the centralized one, you need basically several blockchains interacting to each other, right? And this is called the interoperability problem. How two blockchains or two networks, they can talk to each other, right? And this itself is really very, very challenging problem, right? Interoperability one. So like, for example, in the banks scenario, in the financial scenario, you have a KYC thing. So there is a network, let's say CAMS, Carvi, and those ones, basically they do the your KYC one, right? And then you go to the loan sanction to the bank of, there is a consortium of banks. You go to the loan request, and when you go for the loan, right, you basically show your property papers or show something basically against that you are taking the loan, right? So now if this bank have done this, and if you have already taken the loan from some other bank using those papers, then you cannot take the loan from other banks which is on the same network, and then that blockchain network will see you are complying to the KYC, which is in the another network, right? So communicating inter-blockchain is really a very interesting. What should be my communication protocols? How basically one can understand. So it's just like in databases is a heterogeneity of my blockchain and how to handle this heterogeneity while you are communicating to the different blockchains. It's a very interesting problem. Okay. So the first part, as we saw, the 4 requirements or the characteristics of the blockchain is the ledger, is the part. So ledger is the system of records for a business. Businesses may have multiple ledgers for multiple business networks. So in the network, there is a node. That node is, so let me put it. So there is a network, large network. In that large network, they can form a channels. Channels means basically, let's say in the network, there are node 1, node 2, node 3, node 4. Let's say there are 10 banks, right? Some banks are, my big banks, some are small bank or medium banks. Then within that 10, the first 3 banks basically can make one channel. And then 1, 4, 7, 9, 8 can make another channel, right? So within that, basically, they can have a multiple channel. That means basically that every node can have multiple ledgers depending on which business channel they are participating, right? That's what the meaning is. Transaction, any asset that you transfer onto or off the ledger, right? It goes, you write on that I transfer $20 to that, right? Any things that happens, any transactions. And as I said, contract is a logic that to automate the execution and the settlement of the transactions. So like basically that John gives a car to Anthony, this assets or this transaction will get settled if the money has been transferred, right? So that is what basically the logic says, that under what contract, under what business agreement, or under what basically my other contract, the transaction needs to get executed. Yeah. So now the key aspect of is how to create blocks which are immutable, right? That means that if someone changes the any value of the transactions in that block, the block has value. That is, the block, kind of identify the primary key of that block gets changed, right? So a block is nothing, depending on whatever the size, 512 MB or whatever basically the size of the block is, right? A block is nothing. Block is a collection of transactions, right, with some additional information, right? So in this, basically, as you can see here, that this block 0 or block 1 here has a set of transactions, right? And then it has block number, which is and identify which block number is, and then it has a nonce. I will tell you what is a nonce. And then it has a 2 more things. One is basically that a hash value of this block, which is basically unique value. This is a unique value. That is, if you change anything over here, even if you change one character in this, in any of these transactions, the hash value will get changed, right? So hash value is a kind of big puzzle, very complicated puzzle, that basically in the network, some of the guys or some of the owner on that network basically are generating this hash value, and I'll come to that, how these hash values are generated, right? And then this block 1 is changed with the previous block. That means basically it has the hash value of the previous block. So since it is a block 1, there is no previous block, right? So that's why it is 0, 0, 0. Block 2, it has a hash value of its own plus the previous hash value, which is this. Okay. Now, how this hash value is generated? And this is a millions of questions. And as I said, that in the network, like in say Bitcoin one, in that network, basically there are hundreds of thousands of nodes. Some of the nodes are called miner. Miner, these are the people who are basically calculating the hash value of the block. So if the block size is, let's say, 512 MB, they get all the data. Once it is collected, then they start solving a puzzle, right? That is start solving the computing the value of the hash value of that block, right? Now, you ask, what is the hash value here? Who decides basically what should be the hash value? This is the network. The complete network decides that, okay, we generate the hash value of this length, right? Where the first 4 bits of that hash value should start with 0000. This network decides. So now these guys basically start, right? So now in order to take this, compute this, what they take basically, they take the nonce. Nonce is the input parameter that take the nonce, take the transactions values there, and then they start computing, because this part is my fixed. Transactions are my fixed. What is variable? Only the nonce. So then they keep changing the nonce value and see basically for every nonce, what is the hash value, keeping the transactions fixed. Then change the nonce value. They keep going. They still basically get the hash value with the 4 zeros. Okay, right? And once they get the 40, they stop that and then they broadcast to every party in the network, hey, I'm the winner. They do the self-declaration of the winner. The network has not said you are the winner, but they say, hey, I'm the winner. I have found the hash value, right, for this block, and here it is the hash value for these transactions, right? For these transactions IDs. So they say, okay, transaction ID 12345 to 1000. For these transactions, I have clubbed together, right, in the block, and for this transaction, here is the hash value. And this is right. Now we'll come to the how these transactions get validated. So when they broadcast that, then every party will take that block and see basically in that block what are the tuples that are blocked together. Then they validate these transactions, right, with their own copy, because they have the copy, right, of the transactions. They then validate that if everything is all right, nothing has been changed, then they will accept it. Yes, we accept your block, right? And then they chain that into the previous block. Okay, so that's the idea. Okay, and this is what basically block is they can here just in step by step, the new transactions are broadcast to all nodes. Whenever a new transaction happens, it broadcasts to every nodes, right? Right, and then some of these nodes in this network are the miners, and each miner collects these new transactions into the block. Each miner works on finding the difficult proof of work, that is the hash value. When a miner finds a hash value, it broadcasts the blocks to all the nodes. Nodes accept the block only if all the transactions in it are valid and not already included in the other blocks, right? And they do the validation with respect to the data that they already get, because every transaction is broadcasted to all the nodes, right? The miners express their acceptance of the block by working on creating the next block in the chain using the hash of the accepted block as the previous block, right? And each miner gets some incentives, right? Gets some money, right? And it has been estimated that in the Bitcoin, basically the the miners total electricity that is consumed by the miners is very close or same as basically the total electricity consumed in by Switzerland, right? So you can see the computational power is a huge computational power. Now you can say, hey, if they are getting the money, it's a great business. I can buy 1,000 customers computers, right? And then I can start miners. Yes, you can. Why not? But then the network see, hey, this guy is creating all the blocks. That is basically he's getting his monopoly. The network basically is very dynamic and say, now we don't want 4 zeros. Basically, we want the 5 zeros or we want something else, right? So they can change this proof of work, that is the puzzle. They can make it even more complicated, right? And sometimes basically the networks may reject just to basically not to get that monopoly. So let me see basically how it is done, okay? So as I said, right, the cryptographic hash functions, and I'm not expert of that at all, right? So like these are the basically some hash functions, MD5, SHA-256, these are the some cryptographic hash functions here. So let's say basically you have a input parameter that is a transaction is a fox. And when the input is fox, the transactions, right? Like here you had a transaction, this is the transactions, $25, right? From this, that. Rather than that, you have only the fox. And if you apply this cryptographic hash function, this is the basically the hash value. Similarly, if you say the red fox jumps over the blue dog, apply the cryptographic function, you get the hash. So you get the hash value here. But if you see here, if you change just VYU, only one character, you see basically apply the same hash function, right? You see the complete change in the hash value, right? So it's a small change in the data result is a significant change in the output, right? In these ones. So how this is done, right? Because as I said, this is the main crux, right? All these miners who are getting the incentives basically for generating these hash values and therefore basically Bitcoin, what they do that. So what they basically, they take a random hash function, okay? They take a random hash function, right? And that basically they take a nonce, right? They take a basically the given nonce, and what was the nonce? Like numbers varying 1, 2, 3, 4, 5. They say take that one, and then they find the hash value R. They find the hash value R in such a way that the target should start with first 4 zeros or 2 or 1 or whatever, right? That is what basically they say that. And for that, basically, they just write this very simple one that you solve this puzzle, right? And repeat this till basically you the target value, okay? But this is a very complicated puzzle, okay? So how this is done? So let's say basically you have 3 peers, okay? In that network, you have a 3, P1, P2, P3. And all of them are basically solving they all are miners. They are solving the puzzles. So initially there is nothing. So you start, right? Now basically you create a block, right? X1 basically comes, what is the P1 is done, P1 broadcast this to P2 and P3, that one. And then basically goes and solves that and create a chain, right? And that chain is now that block is now chained with the previous block, right? With having a write all the transactions over here. Now basically second one comes. When the second one comes, basically the second one broadcasts that and then says, hey, I have basically created the block, and here is the block, right? And all its transactions that goes over here. And similarly, P3 does, and so on. So now basically, as you see, a linear chain. Now here is a very ideal case where the blocks are created in a linear fashion, right? But in reality, it doesn't happen in that way, because all these three guys, P1, P2, P3, they all three are basically are the miners. They have a lot of computational power resources, right? And all of them are doing. So at some certain point, it may happen that P3 basically generates a block, and P3 I have done with the X2, and then similarly basically the another peer P4 comes and then say, hey, I basically have also created a block. So two guys, right, more or less same time, they say, I have created the blocks and here are the hash values, right? And they broadcast that. So what they do basically, they temporarily, right, they get both the blocks from created by P3, created by P4, then they get that, they look at what are the transactions in the block created by P3, they validate with their local database. Similarly, they validate for the P4 also, and then basically they just continue, and they don't say basically which one is valid. They do. Then P5 comes, P5 basically goes over here. But in the meantime, basically, either you can say, let's disregard the P3 one, right? P4 and P5 it has come. Or now P3 in the meantime basically has come and also generated the next block and the next block. Then network can decide, hey, discard the P4 and P5. Let's take basically this chain of P3, right? So again, creating the chains of the blocks depends on basically on number of factors. Who are the miners they are creating. The network basically does not accept the block as and when it is created. It waits, right, for the others, right, for the other miners to basically say. Then if there is a too much delay, again network decides till what time they will, till what delay can tolerate, right? And if others come and they broadcast the same, they broadcast basically the blocks having the same one, they basically accept that, and then they keep going, and that is what basically the chain of blocks is created. Okay, so that was the permission one, right? Permissionless one, right? Now let's talk about the permissioned network. So in the permissionless one, you have all independent parties, right? Completely, basically, kind of disintegrated, right? A large number of that, right? And a lot of miners are there, right? There was no control, right? There was no control. Now, in the permission network, whether it's a Hyperledger Fabric or Hyperledger Indy or Hyperledger, basically, and various kind of things are there. The consensus is achieved of doing anything is endorse, order, and validate. And I'll tell you each of them. Okay. So in the network, you have typically basically three types of nodes or four types of nodes. So in the network, basically you have, node 1, node 2, node 3, node 5, node 6, node 7, node 8, node 9, and so on, right? You have hundreds of nodes over here, right, in that network. But this network is somewhat is a controlled network. It's not open to everyone. It is a controlled network, okay? So what they do basically in this network, they decide that, okay, some nodes are my endorsers node. And what are the endorsers node? That they have certain policies, and based on the policies, they go and kind of simulate the transactions. Any transactions which is coming, that will go to everywhere. They will go to everywhere, all the nodes. It will broadcast to all the nodes. But these are the guys, endorsers are the guys who will execute that transaction. But when I say execute the transactions, the output of those transactions will not be written on the database. They should just hold it. Okay, they will hold it. Okay, that is what the endorsers. So a client submits a transactions, right, for the smart contract. So the client says, okay, here is the transactions, and for that transactions, the smart contract A is applicable. Okay, so now basically all these endorsers, right, they will just go and they sign it, and then they start executing that transactions. Okay, so that is one. So now once they have endorsed the transactions, they execute that transactions or the proposal. But none of them, as I said, none of them basically will write the output of those transactions in the ledger. Rather, what they will do, they will do basically what operations they have done, and these operations are always defined in a read and write, right? You know, basically when you from a disk format, basically you just go read the value of data item A, write the value of, right, do some computation, then write the value of item A, right? So they give you the read write sets of for each of the operations, right? So they give you basically, okay, for this, here is the read value, here is the write value, and each of them basically determine independently. So E0 will generate the read write sets for the same transactions here, E1 will do, and the E2 will do, right? Each of them will do. And then what they do, they will submit the read write sets asynchronously to the application. So this guy basically say, okay, for the applications or the transactions that you submitted, here is the read write. This guy say, here is the read write. This guy say, here is the read write. And each of the read write set is signed by each of the endorsers. So they say that read and write is by this, so it is signed by that, it is authenticated by that, right? And in over here, okay? And it may be possible that there may be a version number. Version number means basically that this guy executed the transactions in a database whose version is this, right? And that version may be a bit older because there was other transactions that were coming here, or blocks were coming here, and they did not reach over here. So each record basically has some kind of version number. Okay, so now this guy gets it. Now what this does, they take this, all the read write sets from here for that transactions, they submit this to the orderer. So the application submits the responses as a transactions to be ordered. So this guy is the one who is creating the blocks. Okay, so orderer basically what they do, they take these responses as a transactions, put them in the block, right? And ordering happens across the fabric in parallel, because there are many other transactions that are coming right here, right, submitted by other applications. Okay, so that is number 4, the order transaction. Once the order block is created by them, or the order is done, then they broadcast that information to all the nodes, to all the peers, right, to endorsers and to the other peers also, right? So the ordering service collects the transactions into the proposals blocks for distribution to the committing peers. And what these basically committing, they do that committing one, that is number 6, that what they do basically, that all the blocks that is created by them broadcast over here, that each of the peer will check all the transactions in that block with respect to the information that they have on their own side. So remember, every transactions, it goes to everywhere. So they have the collection. So when this guy create the block, this guy say basically, okay, I have this in this block. Yes, I have this, I have this, I have this, and this is not included in any of the block, right? So there are two conditions, that any block or any transactions should not be included in the 2 blocks, and the transactions should be there without any change in the block, right? And that is what the validations are over here. They do the validation over here. They write apply to the word state, which is basically the summarized or kind of database over here. And if there are any invalid transactions, they are basically also retained in the ledger, but, but not in the word state, and they reject that one. And once they are done, then basically they just go and commit that transactions and they notify to the application. Right? So that's what basically the blocks are created, right? And the transactions are executed. Okay. So now, as I said, the greatest impact from the blockchain is found in 3 areas, right? Which I will cover on the second one. So let me go on that, right? So now the question here is that how my blockchain is interacting with the ledger. Okay. So as a blockchain developer, any blockchain developer, they need to just focus on 2 things: developing the application, writing the code, chain code for the application, and writing the chain code for the smart contract. That's all, 2 things. They should not worry about that, right? And if application accessing anything from the block, right, they have a REST APIs, they can get that one. And when the application, when any transaction or application gets executed, it invokes the smart contract, right? Under what agreement that transaction should go. And this basically emits the events, right? Any kind of events that it emits, right? That basically will go on the blockchain over here, right? It has, the smart contract can have 2 kind of data. Either it can read the data, get the data, that is read the data. When it is doing the reading always done from the ledger state or the word state or the database state, right? When it is basically putting the information, right, then it is just go and writes that block as what basically we discussed, that blocks are created, they basically chain together and so on, right? That's what it interacts on that, right? And this is the blockchain software stack, right? So now let me go to the second part, and here it is showing the third part because the second part I'll be discussing on the next lecture. Now, what are my interesting research problems? Okay, so there are many interesting research areas in the blockchain, and we can typically classify this into the 5 category. The first one is the scalability, and this is very, very important. As I said, if you recall, the degree of centralization, right? If you recall the degree of centralization, right, that you have a left-hand side, you have a complete decentralization. On the right-hand side, you have a centralized one. If you go 100% decentralization, the transaction throughput is very, very poor. But if you go to the right-hand side on the centralized solution, the transaction side is very, very good. You can have basically several database vendors, basically they claim millions of transactions. If you go to the airport, they say basically that, look, if you run without naming any company, if you run basically our things on this performance, we are 10 times better than our nearest competitors, right? The nearest competitor. So scalability is a very big issue. And from a database community, right, what the database community has done, and I think that's the second point here, is that they have built a project called the BigChain DB, where they take the distributed database and build basically the layer on top of the distributed database that basically provides all the characteristics. That is your shared ledger, that is on the privacy, that is the smart contract and the consensus. So they have built on top of that. So it's not a blockchain technology, it is a distributed database technology, but on top of that, basically they support for they support basically all the blockchain characteristics by creating these layers on top of it, right? So that is a scalability. So in the scalability, decentralized one, very poor, roughly like 7 transactions, as you can see over here, is they can per second they are executed on that, right? On a block size of 1 MB. The other is the privacy and confidentiality, right? This is very, although each transaction is highly secured, right? But the question over here is when multiple parties are there in the network, though the data is being written on the ledger, not all the data can be seen by all the parties of that particular node. So how you can preserve the privacy and the confidentiality, right? The third part, we already discussed the interoperability. And interoperability means is that how my different blockchains, they can talk to each other, right? Like it's just like you have a IBM DB2, you have a Oracle, you have a SQL Server, Microsoft, you have other things, right? And they are basically talking to each other because in same organization, you have all these 3 databases, right? And they are talking to each other, right? And so there is some kind of, you write a wrapper or some communication protocol. Similarly, basically, if you have Similarly, basically, let's say Hyperledger Fabric and Hyperledger Indy, how they can talk to each other. And the fourth is very interesting. And this is one of the, obstacle in getting the blockchain more, successful, and which is the economics model. That means what I will get, right, from a financial point of view to get my services on the blockchain. If you bring the heterogeneous organization, so basically take a example of logistic and supply chain. When an item is exported from India to another country, there are multiple parties are there for same transaction, which is getting that things from India to the destination country. Right? There are many parties, the immigration, there is a shipping organization, and then basically there is a handling company, then the insurance company, then get to the next one, then there is another immigration, clearance, border security, and so on and so forth. The multiple parties are there, right? So the question here is, if we need to bring all these parties on the network, what they are going to get it, right? So defining the economics, right, or for the network, so that there is a win-win situation for all the parties, right? And trust me that many people I have spoken to, right, in this, when they are working on the blockchain, they say, hey, we are the very small party, what we are going to get it? We are just one service provider. Why do we need to get the blockchain? What am I going to get, right? If I need to get, then I need to maintain these things. Who's going to invest that money, right? So that's the economics is the big hindrance basically for the successful of the blockchain, particularly for all the parties. And the last but not the least is the governance. That is when multiple parties are involved, right? Particularly in the permission less one, or even the permission one. The many parties are there, right? Who is going to basically govern all these parties? Unless basically you say that, okay, I'm designing this for this, here are the things. So define the governance around the application development and the maintenance and successfully running the network, right? That's it. From a database perspective, right? And I'm taking a database perspective, and there are many other applications that I've listed from a non-database perspective. A very, very interesting problem. And the first really that this problem excites me is called the reference data management. And what does that mean? When the block, let's say, when any application has multiple parties from different boundaries, cross boundaries, right? For example, as I said, let's say we build a network of medical doctors, okay? And the medical doctors from different countries are there in that network. And this network is providing the consulting and the treatment, right, to different patients. Now, that patients basically gets some reports, the doctor report, the blood report, and so on and so forth. And that is replicated everywhere, all the parties in that node. Now they are consulting. When this guy looks at that report, every country has a different measurement and different scale for certain things. So for example, if it is a blood, right, the way we in India measure the cholesterol, and we say, oh, your cholesterol is very high or low, or triglyceride or blood or sugar level, this and that. Every country has a different measurement, right? And this is what is the reference database. So that means that how the other parties across the boundary can interpret that document or the agreement or the smart contract as per the law of that country, right? So there has to be a reference for that, right? And that is what is called the reference data management, right? It's a really very interesting problem, that is how my laws, right, law of one country can be interpreted in another country if something goes wrong, right? On that. On and off blockchain integration. I'm just describing only the highlighted ones. If you are interested, I can go basically for each of these ones, right? So on and off blockchain integration in the blockchain, on blockchain, you have only limited information. But most of the enterprise information is stored in my other operational systems, right? Other non-operational systems, my warehousing and so on. And when you do the analytics cannot be done in silos from one data. You have to integrate blockchain data with the other off blockchain data. It could be even outside the company, right? The data, right? How this integration will take place. Again, all the data integration. How will you define the mapping of that? Because the on blockchain data is the modeling of that. Everything is done through the consensus, right? In that network. That may be different basically of what my enterprise or operational data store understands that, right? So this defining the mapping of on and off blockchain and basically analyzing on and off blockchain data is very, very important problem for applications where you need to access the third party or your own data from different federated information systems. And the smart contract governance, right? How to basically define these contract and the SLA, service line agreement over there, and service level agreements and so on, right? So there are many research. If you look at the data layer, is a multi-storage, right? One. So my different blockchain applications have a different demands on the data model and the query analytics one, right? My Hyperledger Fabric supports a pluggable data store, so you can basically have a data stored in NoSQL or IDBMS or this, right? So how can we provide the pluggable data storage systems? Blockchain platforms handles the simulation and validation steps outside the database, right? Well, we need to see that we want to achieve this certain throughput or certain, parameters. So you have to simulate that outside, right? And the other is what transactional capabilities in the query interfaces are useful for the blockchain applications. Can we optimize the databases for the blockchain, right? So they are very, they have been addressed from a customized blockchain solutions perspective, but from a research perspective, each of these problems is very, very interesting, that how we can do the plug and play kind of things at the data layer level in the blockchain. Okay. Then there are DBMS implications here, right? Not everything basically can give you other things. As I said, that when we are doing the simulation and validations for outside this, how we can provide that, right? And provenance is a very, very important area, but it is not easily queryable. And what is a provenance? Provenance means the source of the data from where it got originated. So in the blockchain, it inherently supports the provenance, because you know where this data got originated, right? And that is why basically you get that data and then you put it in the store on that. But the question here is that when and how and who verified and who can access this information. I generated that information, but then that all other network, basically the data is there and they can modify that information. They can edit that information subject to basically all the smart contract that we have that, right? Which set of the transactions modified a particular data element with respect to the provenance of that. So these are the really very open problems, research problems in this from a database perspective, right? And then trust is other one that, as I said, I'm not the expert on that, but basically making how we can, though the blockchain basically establishes the trust, but then there could be a number of queries basically with respect to CXOs that basically we need to enforce the trust on the databases. Okay? Data analytics is a very important one, and one of the things is analyzing the data at the edge. This is called the edge analytics. That most of the databases or warehousing or any other blockchain data is stored, they analyze the information at the back end. They take the data from the word state, they analyze that information and present that. But analyze the data as it is coming on the network, we intercept that information, right? So it just like basically is that we get an SMS. When we get an SMS, can we analyze that small piece of SMS information? So let's say you get an SMS, you are in some market, you withdrew the $500 debit or credit card, and when you swipe your credit card, you get a thank you very much for using, right, your credit card, blah, blah, on so-and-so merchant and so-and-so location and so-and-so date and time and amount, right? So that means basically we know that where you are, where you have purchased this. You are in Gurgaon. You are in Gurgaon on so-and-so mall, on so-and-so shop. So you analyzing that information as basically comes through, and then probably we might have a other guy on the network. They might be providing you a 20% off on something. So you get a coupon immediately. Right, here is a 20% coupon, right, valid for next 2 hours on, in that area one. Right? And this is called the edge analytics. That as the information coming before it goes to the database, intercept that information, analyze that information, correlate that information, and give the whatever is basically take the actions and move forward. That is what is very important, doing the analytics for the blockchain applications, right? And other is very important, which I will discuss in detail, creating this marketplace, right? And my proposal on the micro insurance is for creating the marketplace, right? On using the blockchain technology and creating the marketplace, whether it's an e-commerce marketplace or this, there has been number of things, right? And I'm not saying blockchain is the only one. Probably blockchain may be a killer here, since we can do the same, creating the marketplace using other technology. But nonetheless, we will look at, can we use the blockchain for creating the marketplace, creating the data economy, and therefore basically driving the analytics from that data, which can provide the better services to the citizen. And we will look at one application of micro insurance on the later part, right? So, right, and there are security and privacy and consensus issues. I'm not expert, but there are very interesting problems, and I can share these slides to you later on, right? So with that, I will here in the first part, right? And let's see basically if you have any questions. We'll be very happy to interact with you, right? And so let's see basically you have any questions. Over to you guys.
Yes, sir. Thank you, sir. If anybody has any questions, kindly raise your hands. Or you can also chat with us in question and answer segment.
Any questions from anyone? I'm not sure whether you really were attentive here or not. Sorry, who are the participants?
Yes, sir. I'm waiting for the questions. We'll wait for 2 minutes.
Yeah, sure.
Yes, sir.
How many participants are there? I can't see them. You all. Deepaji, how many participants are there?
Kindly wait, sir. Yes, hello. Jyoti Yadav. Am I audible to you?
Yes.
Ma'am, you can ask your question.
Good morning, sir. Am I audible?
Yes, you are, Jyoti ji.
Yes, sir. Sir, my question was regarding scalability of blockchain. So I just wanted to know, what are the various solutions possible for enhancing the scalability of blockchain, and what are the research avenues in this particular field?
So you are
regarding
talking about
scalability.
got you. I got your questions. Very good questions. So in the permissionless or permission network?
In permissioned, or maybe in both, like if I talk particularly about public blockchains.
So in the permission network, the 7 transactions that I showed you, which is on the permissionless network, like in the Bitcoin or Ethereum, right? In the permission network, this is a lot more, multiple thousands of transactions. Right? I think these days 10 or 12,000 transactions that you can do that, right? So as I said, there are 2 kind of things that you can do. One is basically that can we do the go based on the majority consensus rather than getting the consensus from everyone. Can we classify, okay, if I have, let's say, 100 nodes or 100 parties on the network, whom do you basically trust more? And that you can get basically from the historical information that, hey, out of, previously they participated in 1 lakh validation, and all these 90% of the people have been 100% corrected all the time, right? So then, rather than wait for for all the 100 people, you basically trust these 90 people. So then this will improve basically your transactions throughput, because you don't need to basically wait for all the 100 one, right? The other is, you can make the transactions the two phases. That is, don't commit fully, right? But give some kind of intermediate things which you have, approximate depending on the what kind of queries are here. If I'm asking, hey, what was the total number of items that was shipped from India to Australia in this particular category, rather than basically you tell, okay, the total number of items was 3,577,000. If you can do approximate calculation, which basically quickly improve the transaction throughput, that may be the one. And the third is, of course, basically that can we put a lot more computational power on that, right? So it depends on basically what angle that you see that, right? But people have been trying. I know basically that IBM Hyperleveraged Fabric, the research team, they have been trying to improve the transactions throughput, right, by number of different ways.
Yes, sir. Thank you so much, sir. It was actually, my question was, related to scalability, because I've been going through the literature of scalability, and they're providing various solutions, because people have, like many researchers have worked on various solutions at different layers. So layer 0, layer 1, layer 2 solutions are being proposed. And there are certain solutions where the transactions are compacted to achieve more scalability, or sharding is also used, is one of the technique, or even the directed acyclic graphs are also used. So I really don't understand, like it's really confusing, like recent applications which are working on blockchain, using the blockchain technology. So is the DAG technology, the directed acyclic graph, is being used so that they get a very good throughput and latency is achieved?
Right. So sharding, any kind of partitioning or those things, they are good for the parallel and distributed databases, where the data is not fully replicated. Here in the blockchain, the data is fully replicated. So I'm really not sure that how my shard, right? I'm not sure how the sharding technology or any partitioning algorithms can be used, can help actually over here. The throughput basically is, see, okay, let me put it in, where we are getting the delayed. In the permissioned network, if I go back here, right, let's say basically here, where am I getting? One is that these guys are generating the read-write set, then sending over here, and then over here they are creating the blocks, and then blocks basically goes whoever will basically broadcast over here and getting that, right? So one is the consensus. The consensus, because everybody is executing the transactions, you need to wait till you get the consensus voting from everyone, right? So the question here is, should if I know basically that Mr. X and Mrs. Y both are basically are not trustworthy because of the historical reasons, right? Probably we do something. And the other is basically depending on what kind of transaction it is. As I said, basically, if it is some kind of analytics related transactions, aggregated information transactions, right? We can give the approximate answer while basically my network is computing in that one, right? So we can divide this transactions throughput. Is not like basically like database transactions throughput that it commits. It is not committing fully. You know what I'm saying? It is partially committed in the sense basically that it has given you the approximate answer.
Yes, sir. Yes, sir. Thank you so much, sir.
Okay,
Okay, thank you, ma'am. Sir, we have another question.
Mhm.
Hello, Sapna Patel. Hello. Sapna Patel, am I audible to you? Okay. I guess there's some problem. Hello, Sapna. Fine.
Move on.
So we also have a number of questions in the chat box in question and answer section. The first question says, what do you think of blockchain implementation in Indian judiciary? Could it be implemented easily or I'm dictating the questions.
Okay, yeah.
Okay, am I able to, sir?
Yeah, you are.
Okay, sir. So the first question is, what do you think of blockchain implementation in Indian judiciary? Could it be implemented easily or will government try to implement? If implemented, what changes could be faced?
Okay. This is a open boundary questions. First of all, Indian judiciary means what? If it is, let's say there is an inquiry where the multiple parties, the CBI or other things, right? Or let's say this judge basically goes over here and judge basically says that I need to get the information from these 5 different parties, right? And now, right? Yes, something blockchain may be used but in this, one party should not know what other party has provided the information, right? So therefore, basically, I don't think that there is a fully deployment of that one. Yes, between judge and that party, whosoever the party is providing the information, there can be a basically because judge and this guy wants to create some kind of trust on that. But to me, this is a overkill. If you want to use in the Indian system, in the Indian in the Indian government system, I think the one of the application that I think of is traceability of the every rupee that goes from central government to the last person. And that is why the government is doing the direct transfer benefits, right? Which has basically removed all the brokers, right? And our late prime minister used to say 1 rupee jata hai, 15 paise pahunchte hain last mein. That you can do in the blockchain. So blockchain, basically you say, okay, the node, so in the blockchain network, you have a central government, you have a state government, you have a district administrations, you have a different vendors, you have a different suppliers and many other parties. Now this 100 rupees from the central government goes for a particular things right over there. So now, and then there is a contract also, there is a rules are defined where this 100 rupees should be spent on, blah, blah, blah. 100 goes to the state government basically passes to that, and then they say, yes, 100 rupees passes to that, right? They cannot directly distribute that. So every party is now accountable here, and they can write the things on the network, bring the complete transparencies so that the central government can see that 100 rupees that they transferred, the things for the some purpose has been transferred to the end user or not, right? Now suppliers know basically whether they have supplied that items, how much they have quoted. So there I see the use of the blockchain, right? But
Okay,
Indian
thank you so much,
judiciary,
sir.
there may be, right? There may be, yeah. Go ahead. Last question I'll take.
Yes, sir. Sir, actually, we can take other questions in coming sections because it's time for the common inaugural of
Okay, sure.
Atal FDPs.
Okay, all
So,
right.
thank you, sir.
Excellent.
Thank you so much, sir. Participants are kindly
Okay.
requested to join the inaugural. on the YouTube link that is given to you. It is also mentioned in the chat box. So all are kindly requested to join the common inaugural and follow the schedule
Okay.
that is given to you in the FD.
Yeah,
Thank you.
I'm just stopping, sir.
Yes.
I'll see you then. Thanks.
Yes.
Bye.
Next session will be at